Did you know that some animals seem to break evolution? Not because they are unusual, but because they retain traits that, under typical evolutionary pressures, should have been replaced. Evolution is often understood as a process of gradual refinement. Traits that improve survival tend to spread, while less efficient ones are replaced over time. In many lineages, this leads to clear directional change, but that pattern is not universal. Take early mammals. The ancestral condition involved egg-laying, a trait inherited from reptilian ancestors. Over time, most mammals evolved live birth, which allows for greater protection and internal development of offspring. This transition is seen in the vast majority of modern mammals. Yet, the platypus still lays eggs. By standard evolutionary expectations, egg-laying would have been replaced. But in the platypus's ecological niche, it remained viable, so the transition never occurred. Meanwhile, other mammals, from rodents to whales, followed the more typical evolutionary path toward live birth. A similar contrast appears in amphibians. The expected life cycle involves metamorphosis, an aquatic larval stage followed by a terrestrial adult form. This shift allows access to new environments and resources. Frogs are a classic example, transforming from gill-breathing tadpoles into air-breathing adults. But the axolotl never completes this transition. It retains its juvenile features, including external gills, throughout its life. While most amphibians undergo a clear developmental progression, the axolotl remains in a larval state because its aquatic environment removes the pressure to change. Fish evolution shows a similar pattern. Lobe-finned fish are understood as the ancestors of land vertebrates. Over time, this lineage led to animals capable of supporting their weight on land, eventually giving rise to amphibians, reptiles, and mammals. This represents a major evolutionary transition from water to land. However, the coelacanth retains many of these ancestral features. Rather than continuing along the path toward terrestrial adaptation, it remained in a deep-sea environment where those traits were sufficient. In contrast, early tetrapods continued the transition, developing limbs capable of bearing weight outside water. Even body plans can remain unchanged when they are already effective. The horseshoe crab has maintained a similar structure for hundreds of millions of years. While other arthropods diversified into countless forms, its design persisted with relatively little change. Meanwhile, related groups such as arachnids and crustaceans evolved a wide range of specialized adaptations. So why do some species change, while others remain relatively the same? Evolution does not operate with a goal. It does not push species toward complexity or improvement. Instead, it responds to selective pressure. When environments shift, competition increases, or new opportunities emerge, change is favored. But when conditions remain stable and a trait continues to function effectively, there is little pressure to replace it. In this sense, evolution is not a ladder. It is a branching system of outcomes. Some branches continue to change, others stabilize. And the animals that seem to defy evolutionary expectations are not exceptions to the process. They are evidence that sometimes the most successful strategy is not to become something new, but to remain exactly as they are.